Hello, ma'am.
Hello, good evening.
Good evening.
So how are you?
I'm good. How are you?
I'm fine.
Yeah, I'm just stressed out with the work, that's all.
Okay. I'm trying to open this, share this PPT. Can you see this PPT, Principles of Material Handling?
Yes,
Not
ma'am.
yet.
Not yet. I don't know what's the problem. Now you can see it. The 10
Yes, ma'am.
principles.
Yes.
Okay, so let's start it. Today we'll be doing material handling. Can you see it?
Yes, ma'am.
Principles of material handling.
Yes, ma'am.
Okay. Actually, one of the reason how you can improve your product, there are many other factors which we have already done, but proper material which required for running the operation plus technology, all these things help you in making your productivity better. The key to greater productivity, customer service, and profitability. Naturally, if your productivity increases, that is, productivity is what? What from the output you get from the desired input. If you put proper input, then only you can uh, aim for the desired result. And if you get the desired result, then only you can satisfy your customers. And if you satisfy your customers, naturally profitability will come. Because if the customers are not satisfied with your goods or services, whatever you are doing, whatever your operation is, naturally the profitability which you are expecting will not come. And maybe next time they will not demand your good or service. So it is very essential that these three things, productivity, customer service, and profitability, they are interconnected. So there are 10 principles of material handling. So first is your planning principle. Anything in management, you start with planning. Suppose if you are, like, for example, even as a layman, we, before going to bed, we plan what all things we will be going doing tomorrow. Maybe we don't take it, write that in a page and paper, and right, but at least in your mind you think about it, what you are going to do tomorrow, how you will be, at what time you should get up, what should you be the first thing you will be doing. So without planning, if you do something, the result will be not the way you want it to be. If you want to achieve your objective, the first thing you should do, whatever you are doing, you should plan it beforehand. So naturally, material handling also, what type of material you want, what type of material handling equipment you want, all these things have to be planned properly. Uh, Yanchika, you read it. Hello, hello.
Hello? Hello,
Uh,
ma'am, I can't see the slide.
can you see it now?
No, ma'am. The first one is. Yes, ma'am, now I can see.
The first is planning principle.
Yes,
Can
ma'am.
you see it now?
Yes, ma'am. All
Some problem.
material handling.
Should be the result.
Yes, ma'am. All material handling should be the result of a deliberate plan where the needs, performance objectives, and functional specifications of the proposed method are completely defined at the outset.
So actually, before you should know ki what type of material you want, at what time you want what. Like for example, suppose if you are making a furnitures, or say just tables. So table, you need a top, you need to make the four legs of the table, things like that. So you won't be requiring all the material at one time. Maybe first you make the tops of all the tables, then you make the legs of the. So at what time, what is the need, what performance objective you want, what functional, what type of a design you want, functional specification of the proposed method, all everything has to be planned properly before you actually start the work. Next definition. Yes, Anchika.
A plan is prescribed course of action that is defined in advance of implementation. In the simplest form, a handling plan defines the material, what and the moves when and where. Together,
Hmm.
they define the method, how and who.
Hmm. So three things are required: what you want, where, when and where you want it, how it moves from one place to other, and in what process you'll be doing, how and who. Uh,
Key points.
hmm.
The plan should be developed in consultants between the planners and also who will use the benefits from the equipment to the employed.
Hmm. So it is,
Such
the
yes, ma'am.
whatever we are planning, it is not only one man's job. It is also who will be using it, what they want. Because after all, you are not doing anything in vacuum. You are doing to satisfy certain customer needs, their wants. So you should also take that into consultation. Yes, continue.
Success in planning large scale material handling projects generally require a team approach involving supplier consultants when appropriate and in end user specialists from management engineer, computer and information system, finance and operation.
So you
The
need
met- yes, ma'am.
team approach. Everyone is involved. The suppliers is involved, consultant wherever they are required. Then end user specialist, somebody who can tell you about who will be using that particular thing.
Yes,
People
ma'am.
from management, engineering, computer and information system, finance, operation, every branch like should come together and do the planning. Then only you will be successful at the end. Yes, material
The met-
handling.
the material handling plan should reflect the strategic objective of the organization as well as the more immediate needs.
As I told you, like anything, you start with the strategic planning, long term planning. Let's suppose you are going to start a new type of passenger cars. So that is a long term. Maybe that is because that you take, you match both your own strength and weaknesses with the opportunity and threats that is present in the environment. So suppose there is a want the opportunity is there, then there might be competitors, so that those are the threats, or maybe the political situation of a particular, or the cultural, some threats are there. So you have to match all these things, and it is a long term planning. But these have to be converted into tactical planning, which each functional area of that particular organization is going to play in achieving that objective. And also the operational planning at the daily level or the weekly level, what you have to do to achieve that particular thing. Like suppose you are planning to make a car, so that is your strategic planning. But then what the finance should do, what operations should do, what HR should do, what marketing should do to achieve that objective. Then in the finance, every day what you have to do. Then in HR, what each person has to do, what because everyone will not be doing the same job. What the person will be doing daily, and who will be accountable if something goes wrong. Everything has to be planned in advance. Again, we'll continue with planning principle. Yes,
Yes, ma'am.
Yanchika?
Yes, ma'am. The material handling plan should reflect the strategic objective of the organization as well as the more immediate needs. The plan should document existing method and problem physically and economic constraint and future requirement and goods goals.
So uh, you have to look at it has to be documented, because see, it should not be people oriented. Maybe some people know about it, but if it is not documented properly, what will happen? Suppose for some reason or other that person leaves or falls sick, or for example dies, so all the knowledge is gone, whatever he had or she had planned in his mind. So if it is documented properly, then it is can be easily shared with everyone, anyone who is involved in that planning process. As I told, it has to be a teamwork. Everybody should be involved in planning. The one who is supplying the material, any consultant, anyone from management, from finance, from operation. So they come together. So documentation helps you in that also. Plus storing the information permanently. So, and you have to identify what physical and economic constraints you are going to face, what are the future requirements, what is your goal. Everything has to be planned properly before you actually start that operation. Yes.
The
Planning.
plan should promote concurrent engineer of product process design, process layout, and material handling method as opposed to independent and it's sequentially designed practices.
So plan should when what type of a material you want, what are you producing. As I talked about a car, so what engineering requirement is required for producing that car, what process design will be used, where you will be laying out your plant. So all these are interconnected. You cannot say that this is according to the your market, or according to the raw material availability, what process you are, whether you are going to use product out layout or process layout. All these things has to be at the planning stage only, has to be clarified. What, how to handle, from where the material, what type of material handling you will be required, conveyor belts or trucks or chutes, whatever, because different types of material, different type of requirement is required. Things, all this has to be uh, planned before starting the operation. So it is not independent. Everything is integrated. The second is your standardization principle. Like we had said, 10 principles. The first was your planning principles. Second is your standardization principle. Suchandra, you read it.
Sure. The standardization principle.
Mhm.
Material handling methods, equipment, controls, and software should be standardized within the limits of achieving overall performance objectives and without sacrificing needed flexibility, modularity, and throughput.
So, see, standardization is very essential because if you don't have the actual what type of standardization you need, if it is not specifically made clear to everyone, then naturally there will be a lot of conflict, and that will affect the productivity of that. So you have to see what material handling methods you are going to use. That has to be of one particular standard. Maybe you have to study the industry before starting the operation and see what others are doing, how they are doing. If you can bring some innovation in their methods so that you can do a better job, what type of equipment you require, what type of controls you require, what type of a software you require, all this, and there has to be of a standard performance which is acceptable by everyone, because you are not working in isolation. And naturally it has to be something you should not do in the air. What you can achieve, it has to be achievable. Otherwise, planning and making standards which are very high, and if you are not able to achieve it, like for example, as a student also, you have to see what is your capability, how much you can achieve. But everyone cannot, every time everyone cannot top, but you have to see your own capability. So whatever you can achieve, your performance should be the standard which you will be using is of that. And naturally at the same time you have to see it is the system is not rigid, and it is modular. We go for modularity because everything you cannot go in one go. So do it in different modules and introduce each module as the time comes. uh, yes.
Uh,
Suchan?
yeah,
Mm,
the definition for
mm.
the standardization principle. Standardization means less variety and customization in the methods and equipment employed.
So standard means less variety. See, less variety, but it has not need not be rigid. Flexibility also should be there. So you have to make a balance between rigidity, variety as well as rigidity, and some customization has to be there so that each people will understand it better. Yes, Suchandra.
Uh, yeah, standardization principle key points.
Mm.
The planner should select methods and equipment that can perform a variety of tasks under a variety of operating conditions and in anticipation of changing future requirements. Standardization applies to sizes of containers and other load forming components as well as operating procedures and equipment.
Here, standardization is easier, like containers, load forming components, operation procedure. But in some time, somewhere where the same level of standardization, you cannot have very rigid. So you have to plan it in such a way that if certain uh, changes are to be made in the future, because you don't know how things are going to change in the future, what is the future requirement, if certain, so you will should be able to accommodate it.
Standardization, flexibility, and modularity must not be incompatible.
Mm. So as I told you in the, you have to have standardization as well as flexibility and modularity. They should go together. It is not that if it is standardized, so it is very rigid. In that standardization also you have to see things, it is a dynamic system, it is not a static system. So it, whatever changes you have to make, so that some degree of flexibility should also be there, and modularity, because maybe you cannot do, like for example, if you take the software ERP, enterprise resource planning, what it does, it integrates everything which was done in isolation previously, like some, just take the four functional area of management: HR, operations, marketing, and finance. So maybe in the when you're introducing this uh, standard way of doing the things and introducing this information system, maybe you are not able to do it everything in one go. So maybe you can introduce just one module of HR, then after when it has been working successful, you can introduce the other module, then the third module, then the fourth module. So modularity should also be a part of your, in the standardization. This should also be kept in mind. Maybe if you are not able to do it in one go, do it in different modules. Then third is your work principle. Yanchika?
Work principle. Material handling work should be minimized without sacrificing productivity or the level of service required of the operation.
So material, how you are handling the material, how you are bringing the material to the organization, how you are processing the material for the performance uh, of getting the output, the desired output. So it should, unnecessary movement should not be there. It should be minimized so that you don't waste, because that is not going to increase your productivity. Unnecessary movement, maybe like for example, if you go to Banaras Locomotive Works, at the end, when once the electric engine is made, it should go to the wherever it is required. So naturally, it is an engine. It won't be taken on a truck and transported to the place where it is. So it is connected with a railway line, the output, and so it goes directly to wherever it is required. Sometimes it is required by even by some other developing countries. So it can go to the port, where from there it is shipped to the place where it is required. So productivity work principle is that material handling work should be minimized without sacrificing productivity. Like it should not be minimized in such a way that the productivity is affected, or the operation. So you have to keep this in mind, unnecessary work, because that also adds to the cost, and unnecessary delays your productivity. Yes, Yanchika?
Definition. Yes, ma'am. The measure of work is material handling flow, volume, weight, or count per unit of time multiplied by the distance moved.
Work, we, in physics also we say, na, work done is what? Distance moved by the, how much, what is the load of that particular thing.
Simplifying process by reducing, combining, shortening, or eliminating unnecessary moves will reduce work. Consider each pickup and set down or placing material in and out of storage as distinct moves and component of the distance move.
So whatever, like there is always a movement of material. Na? There come, but raw material is coming, it is being stored somewhere. From there, it is being taken to the place where it is being used in the process and being converted in the output. So whatever movement has to be, so as far as possible, unnecessary movement should be avoided. And each thing, from where it is being picked up, from where it is stored or shut down, or placing material in out of storage. So these are distinct moves. So, and it has to be specifically seen that these things are moving smoothly, not in a haphazard manner. Yes, Yanchika.
Ma'am, it is the same slide. Okay. Process method, operation sequence, and process equipment layout should be prepared that support the work minimization objective.
Hmm.
Where possible, gravity should be used to move material or to assist in their movement while respecting consideration of safety and the potential for product damage.
Mhm. See, like sometimes, if suppose in a manufacturing unit, something is being brought down wherever necessary, power will also be less. Less power will be consumed if it is comes down because of gravity. But at the same time, it should not damage that material, and also it should not damage anyone's safety is also of the workers working in that unit should also be taken into consideration, and where so all these equipment and layout should be prepared that this the objective of minimizing the movements that should always be there.
The shortest distance between 2 points is a straight line.
We know that what is the shortest between 2 points. That is the straight line. So if you are going from, if the material is going from A to B, suppose the material is so don't go in a curved way because that will take a longer route, and naturally longer route means more money will be involved in transporting the materials. So try to take the shortest in principle, but every time if it is not possible, at least try to take that curve which is not the longest, it is the shortest. Then comes the agronomic principle. Suchandra, Suchandra.
Yeah. Human capabilities and limitations must be recognized and respected in the design of material handling tasks and equipment to ensure safe and effective operations.
Mm. Like today, because of these things, we are using robots for all those operations which are hazardous or unsafe for the human life. So human capabilities and limitation must be recognized and respected when you are designing the material handling task. How it has to be so that it does not adversely affect the human life, because that is the most important resource of any organization. The whole operation is safe, and it is also able to produce the desired result. Yes.
Ergonomics is a science that seeks to adapt work or working condition to suit the abilities of the worker.
Like for example, suppose you are working on a laptop, so it will depend upon what is your height, where to place the laptop, from where you are comfortable in working. It is not, does not give you unnecessary stress. Suppose if you are bending down too much, then also you will get back pain, you won't be able to work for a longer time. So you have to design the table where that person sits according to his physical capability. Everybody will not, suppose by chance somebody is very short. So naturally some stool or something has to be given, maybe higher level stool has to be given to that person so that he or she is able to work on the laptop. I'm giving just an example. So uh, here agronomic means how the physical capability of the workers are taken into consideration when you are designing the equipments on which they'll be working. Yes.
Uh, Equipment should be selected that eliminates repetitive and strenuous manual labor and which effectively interacts with human operators and users.
Hmm.
The ergonomic principle.
Hmm.
Okay, go ahead, ma'am.
No, no, okay, continue.
The ergonomic principle embraces both physical and mental tasks.
Hmm.
The material handling workplace and the equipment employed to assist in that work must be designed so they are safe for people.
Hmm. See, whatever, suppose a task is, like for example, why do we computerization, one of the basic help which we get from computer doing a repetitive task. So the manual labor is not. For example, when you are making a bill, it is not a very difficult thing. What you do in a making a bill is what, uh, price of one item into the number of item purchased, and then you suppose you have bought up n such items, then you add up. So this is not a very difficult thing to do, but it is boring and repetitive things you have to do. So over here you can use even a calculator or a laptop, anything which will help you in achieving it. So manual and strenuous labor which gets you bored and unnecessary mental and physical fatigue, you can overcome that. You can use equipment which will help you in doing this job in a more uh, in a way which will enhance your productivity. Both your physical and mental work you are doing has to be reduced through these equipments. So it has to be designed. For example, uh, the temperature in which the optimum temperature in which you should be working, so that you feel nice working over there, and you can give your best to best effort in producing that particular thing. So everything has to be taken into consideration, looking at the physical and mental capability of the workforce. Then next,
You, Unit
Yanchika, now you read it. Now we have changed the principle, na? From
Yes.
agronomics, we have come to unit load principle.
Unit load principle. Unit load shall be appropriately sized and concrete in a way which achieves that material flow and inventory objective at each stage in the supply chain.
So what should be the what each operation is different, so you cannot take the same unit load everywhere. So you have to see what unit load you should take. Definition.
A unit load is one that can stored or moved as a single entity at one time, such as pallet, container, or toted,
Tote.
regardless. Sorry,
Huh.
ma'am.
Tote.
Tote,
Huh.
regardless of the number of individual items that make up the load.
So depending upon what unit have to take, one single entity at a time, what you can take. Maybe somewhere it can be 1 kg, somewhere it can be 10 kg. You can suppose it is quite a big manufacturing unit, you can transport 10 kg of material from one place to another. So that becomes, every time you take 10 kgs at a time. Somewhere you can take only 1 kg at a time. Or the container, the size of the container, somewhere you can use a larger container depending upon the space, depending upon the type of material which you are handling. So when you are planning these things, you have to see what should be your unit load.
Less effort, less effort and work is required to collect and move many individual items as a single load than to move many items one at a time.
Hmm.
Load size and composition may changes as material and product move through stages of manufacturing and the resulting distribution channels. Large unit loads are common both pre and post manufacturing in the form of raw material and finished goods.
Say for example, like you have to transport say 10 boxes. So taking one box, then the second box. So if it is possible, if you can take 10 boxes, maybe every time you take 10 boxes, so that makes your movement, number of movements also less, and handling the, see, you cannot have for your own manufacturing unit, you have to decide what should be your unit load at once, at one go, how much you can take it. If you can take it more, it will make your job easier. If it is becomes hazardous, or it affects the productivity or the physical capability of a person or a machine, then also you should avoid it. You should, what is the optimum level? Deciding the unit load is very important.
During manufacturing, smaller unit loads, including SKU as one item, while less in process inventory and shorter item throughput times. Smaller unit loads are consistent with manufacturing strategies that embrace operating objectives such as flexibility, continuous flow, and just in time delivery.
So you, it says, see, as I told you, it is not, unit load is not fixed. That we are talking about unit load. For you, what is your unit load? Maybe it can give you more flexibility, one at a time, or two at a time, or 10 at a time. It depends upon what gives you more flexibility, and it has to be continuous. Like one at a time means continuously one at a time is going, or two at a time is going, or or you want it just in time delivery. So how much you want to take it? May 10 units at a time, but it has to be continuous, and flexibility has to be maintained.
Unit load composed of mix of a different items are consistent with just-in-time and or customized supply strategies so long as item selectivity is not compromised.
So maybe unit load, you can take different items also. One in one unit load, maybe you have taken, there can be different components of a machine. So not taking one component, then the second component, but whatever is required, one of each. It depends how you will choose it, how much you want, so that your selection is very sensitive over there, so that your work is not hampered, movement is also minimized, and you get the desired result. Hmm. Now, Suchandra, we have moved to space utilization.
Yeah. So, space utilization. Effective and efficient use must be made of all available space.
So, whatever is available to you, how you store it, how you utilize that space. So, it is very using the right thing in the right way, right place, where to store it, wherever is that equipment required. If you suppose you store everything, keep it in the store all the time, and maybe some things you keep at the shop floors, so immediately it can be used wherever it is required, and keep that flow going on. When it is over, then bring the next batch from the store.
Space is material handling is three-dimensional and therefore is counted as cubic space.
Naturally, spaces, any space means it has height, it has breadth, and it has length, three-dimensional. That is a cubic. Cube means three. So that is known as space. Yes.
Work areas, cluttered and unorganized spaces, and blocked aisles should be eliminated.
Naturally, like for example, even in your own house, if you keep things cluttered, you will not be able to locate things when it is required. So these things should be unorganized space where things are not kept in an organized, maybe in a wherever, when it suppose that something is required, what is the first thing is required, that should be kept at the first point, then the second thing, and fourth in some sequential order as it is required. It should not be dumped somewhere, and some place should not be blocked by some garbage or something like that. So all this will hamper your workflow. Second, in storage areas,
In storage areas, the objective of maximizing storage density must be balanced against accessibility and selectivity.
uh, there also it had to be kept in the storage area, also it has to be kept in a systematic way. So the balance, how easily you can get it. Like for example, we generally we use two types of random access memory or sequential memory. So you have to see in which way you have to keep it, so that whenever you require it, it is easily available to you. Sometimes, like for example, the letter box in a large building, it is in a random access memory. So where a person, when he or she is checking whether some letter or something has come in his mailbox, he does not have to go through all. It can go directly to the space allotted to him or her. So you have to see how you are, and sometimes in a long playing record, it is in sequential order, because over there you don't want immediately. You can access something and then come to the desired uh, equipment or material, whatever is it. So you have to see how it has been stored, so that the accessibility and selectivity is maintained. Yes.
In work areas, cluttered and unorganized spaces and blocked aisles. Oh, sorry. I was
Third
Yeah.
one.
Yeah, when transporting loads within a facility, the use of overhead space should be considered as an option.
Option. See, for example, like when you're transporting, like must have seen in manufacturing units, especially, you have overhead cranes also. So that space is also utilized. You don't have to take everything from the floor area. You can use that space. Transporting loads within the use of overhead space should be considered as an option. That is one also that also has to be considered. So the movement is also, and it is faster and more accessible. Uh, Yanchika?
Yes, ma'am. System principle. Material movement and storage activities should be fully integrated to form a coordinated operational system which span receiving, inspection, storage, production, assembly, packaging, utilizing, order selection, shipping, transportation, and handling of returns.
Hmm. So these are the things which have to be done. Activities should be fully. So they have to be an integrated way. It is not in an isolated way. Operational system which, like receiving the raw material, then once it is inspecting the raw materials, then storing the raw material where it has to be stored, so that it reaches the production at the place of production in the minimum time and whenever it is desired. Then the production, how it is being produced, what process you are using, where once the different components are produced, where it is being assembled, after being assembled, the packaging, then unitize in what unit it has to be packed. Maybe only one unit has to be packed. Somewhere it may be some other way a place it might be packed 2 or 4 or 5 unit at 10 use. As I told you, that unit load. Then order which is being received by the, how it has to be selected, which order has to be given priority or not. Then once it is being order has been selected, then shipping the finished good to that consumer or the warehouse or the retailers, wherever it has to be go. Transportation, how it has to be, like for example, if it is a perishable item like a food material, then maybe you might need in your transportation system, you might need refrigeration. Maybe it is not, then you might not need. So it depends upon what type of transportation with transportation also you can have by rail, you can have by sea, you can have by air. So it depends upon what and where you are sending. And once, suppose, as I told you, in supply chain management, it is what? Right from the time you have it, the things are moving from raw material to manufacturer, manufacturer to wholesalers, wholesaler to retailers, retailers to final consumer. But in case so the consumer does not like some it, then it should also have the option to return it. So how you are handling that returns, how to handle it, whether you want to just dump it as a useless product, or maybe some rectification is required, and then again once that rectification is done, it has to be again shipped back to the consumer. So handling of returns is also a part of your supply chain. Yes.
Definition: a system of collection of interacting and or interdependent entities that form a unfin whole.
System means ki there are number of interacting entity and they work as a union to achieve some objective.
System integration should encompass the entire supply chain, including reverse
Logistics.
logistics. It should include supplier, manufacturer, distributors, and customers. Inventory level. Sorry.
Yes, yes.
Inventory levels should be minimized at all stages of production and distribution while respecting consideration of process variability and customer service.
So as I told you, the whole system is what supply chain is, from raw material to the finished good, and from the finished good it goes to the consumer. And in case consumer does not like it or has some problem with it, it has the we have reverse logistics. It has to come back to the manufacturer. So whatever is the problem, that has to be rectified. Then inventory level at each level has to, as I told you, inventory is something which the finance is locked over there. So you have to, there should not be opportunity loss or actual loss. If both of this, you have to see, as an inventory we had studied, there's two types of cost. One is your ordering cost, one is your carrying cost. The carrying cost will keep on increasing as the things which you are storing moves up, and the ordering cost will decrease. So you have to take the minimum point where these two curves meet. So we have to, but we have to see the process variability and customer service should not be affected. It has to be in sync with these two demands. Yes.
Information flow and physical material flow should be integrated and treated as different activities. Method should be provided for easily identifying materials and products, for determining their location and status within the facilities and within the supply chain, for controlling their movement.
So as physical information flow, like for example, today, so it is very easy. You order a pizza, suppose, immediately you know how the information, you can follow the route. You, or anything you order online, not only pizza, anything, you can follow the flow of the material. Where suppose you have ordered some food, whether it is being prepared, whether it is on the way, at what time it will be reaching you, the physical flow and the information flow have to be together. It has to be integrated. It is a concurrent activities, because actually you waiting for the physical good, not the only if information is reaching you, but the actual physical food material is not, it is useless. You are not you just don't only want the information that it is reaching you, but it is actually the physical. So these three things to go together. And methods should be provided for easily identifying materials and products, for determining their location and state. So you know exactly if you are following the route, the information, at what stage it is there. With the improvement in your information technology, now all these things are possible.
Customer requirement and expectations regarding quantity, quality, and on-time delivery should be met without expense.
So that, because see, after all, whatever operations we are doing, objective is to satisfy the so what are their expectation, what are their requirements, at what time they want the quality, the quantity, all these things. It should not be without exception. Every time it has to be fulfilled. The principles has the system has to be designed in such a manner that these basic requirements and expectation of the customer has to be fulfilled. Now, Suchandra.
Automation principle.
Hmm.
Material handling operations should be mechanized and or automated where feasible to improve operational efficiency, increase responsiveness, improve consistency and predictability, decrease operating costs, and to eliminate repetitive or potentially unsafe manual labor.
Hmm. So automation comes over here because we want to make the whole operation more efficient and easily responsible to whatever is the demand. Improve consistency when it will reach you. As I told you, because of the information system, we know now we have ordered something online, but we know when it will reach you. Some information flows to you and it shows you, in some cases, it also shows you the whole operation. Actually, not actually, but in virtually, you can see the whole operation, at what stage it is. So these makes your repetitive task less boring and also more productive. Definition, automation. Suchandra, continue.
Automation is a technology concerned with the application of electromechanical devices, electronics, and computer-based systems to operate and control production and service activities.
Hmm.
It suggests the linking of multiple mechanical operations to create a system that can be controlled by programmed instructions.
So this is the basic definition of automation. It is a technology which the the repetitive and the boring task, the safety, all these things into consideration and makes the production system more productive. Yes, continue.
Pre-existing process
Hmm.
and methods should be simplified
Hmm.
and or re-engineered before any efforts of installing mechanized or automated systems.
Hmm.
Computerized material handling systems
Hmm.
should be considered where appropriate for effective integration of material flow and information management.
Because gradually we are seeing that everywhere we need the information flow, and for this we need a computerized system which is about the whole material handling. Then Priyanchika, environment.
Environmental principle. Environmental impact and energy consumption should be considered as
Criteria.
criteria when designing or selecting alternative equipment and material handling system.
So because see, whatever operations which we are doing, it is also sometimes it is also adversely affecting the environment. So whatever for example, if you take coal industry, so that is, So we should take these into consideration and try to design a system or to up for example, if you are there are so many, maybe if you look at uh, all these tissue rolls or paper napkins, for this trees are cut down, which is adversely affecting the environment. So we should do something along with it to replenish it, and so that whatever damage has been done to the environment, rectifying measure has been simultaneously taken.
Environmental consequences stems from a desires not to waste natural resources and to predict and eliminate the possible negative effects of our daily actions on the environment.
As I told you, some rectifying whatever, if you're depleting the environment in any way, try to do something so that it is rectified.
Containers, pallet, and other product used to form and protect the unit load should be designed for reusability when possible and or biodegradable as appropriate.
Like,
Yes, ma'am.
like for example, today we are talking so much of eliminating plastics because it is adversely affecting our environment, and not only our health but even our animals health. So wherever possible, we should be able to use the same container over and over. Reusability of container is possible. Uh, it can be biodegradable so that it does not affect the environment adversely. Yes.
System design should accommodate the handling of spent dunnage, empty containers, and other byproduct of material handling.
So the waste, which, see, for example, today we have so many places which where wastes are dumped, industrial waste, and that is causing environmental harm, and that is why we are experiencing this climate change. So the environmental principle should be also part of when you are designing the whole process.
Materials specified as hazardous have special needs with regard to spill protection, compressibility, and other risk.
Like for example, if it is radioactive element, so we have to see it is, whenever it is disposed properly, so it does not harm this, not only the human life but the any life on the earth, and other risk. Suppose something which is combustible easily catches fire, it should not be dumped just like that. If anything happens and it catches fire, and it will lead to lot of problems for the people living in that area, plus to the environment as a whole. Suchandra?
A life cycle cost principle. A thorough economic analysis should account for the entire life cycle of all material handling equipment and resulting systems.
So right from the time when you are starting, you are getting the raw material, to the time when you are finally reaching it to the consumer, the whole life cycle cost has to be taken into consideration.
Definition.
Uh,
Life cycle costs include all cash flows that will occur between the time the first dollar is spent to plan or procure a new piece of equipment or to put in place a new method until that method and or equipment is totally replaced.
So this is quite like from the time you start to the time, and then so that total cost, how much is it cost to produce that particular equipment.
Life cycle costs include capital investment, installation, setup, and equipment programming, training, system testing, and acceptance. Operating labor utilities, maintenance and repair, reuse, value, and ultimate disposal.
Mm.
A plan for preventive and predictive maintenance should be prepared for the equipment,
Mm.
and the estimated cost of maintenance and spare parts should be included in the economic analysis.
Analysis. So all this cost, everything, invest, initial investment, setting up the equipment, training programs, system testing, all this, all the cost, each and every, even a minutest cost should be taken into consideration. So that, because these financial things matter a lot. Everywhere, if you can save, you will be, it will be affecting the final price of the product. And in this competitive environment, that is the one objective we are looking. We are trying to produce the highest quality at the lowest cost. Hmm.
A long-range plan for replacement of the equipment when it becomes obsolete should be prepared.
Right. Hmm.
Although measurable cost is a primary factor, it is certainly not the only factor in selecting among alternatives. Other factors are a strategic nature to the organization and which form the basis for competition in the marketplace should be considered and quantified whenever possible.
Possible. So long range, because see, after all, equipment is also not everlasting. At certain time, it will get, it will deteriorates with time. So you have to replace it. So the total, when you're making the plan, this long range plan for replacement also should be there. Where to replace it, how to replace it. Maybe next time you might get a better equipment, replace that older thing which had some lacuna, or some, or maybe technology has improved, so now you use a better technology to do the same job.
Ma'am, I think this specific principle
Huh.
applies to certain products as well,
Mm.
but then I think companies, uh, so if you look at certain products, right?
Mm.
So people tend to done with the product after certain period of time, right? But
Huh.
how companies can retain with customers with a limited lifetime products, right? So I think they should evaluate um, the the to retain the customers for a lifetime, right? Lifetime of the company. So what I mean to tell is, so I work for a company.
Hmm.
I hope this is not live streaming, but yeah. Um, so so what I observed, right? So I work for a company, Curology.
Hmm.
So where we uh so we look at the skin of the customers and then create customized skincare solution for that
Hmm.
particular customer or
Hmm.
user. Now, if I look at a different perspective, right? So as soon as they get rid of their skin in natural or whatever, however they want,
Hmm.
they'll tend to stop the subscription.
Hmm.
So, but because of this life cycle principle, now I'm realizing that, okay, so now let's say they are done with the skincare, right?
Hmm.
Their skin looks good and amazing, which is good.
Hmm.
But now, how do I retain the customer back?
See,
Is
in here, once that whatever problem they are having and it has been cured, so it is not that you might be getting some new customers, because this
right,
disease, whatever is the problem is, has not been eliminated altogether.
right.
Like a doctor, eh, does not mean that one person is cured, so his practice is stopped. Not that
No,
he'll get another patient in place of the
right, right,
first
absolutely,
one.
right, absolutely, ma'am. I agree with your point.
Hmm.
But then my point here is that so if you look at that perspective, the revenue will be constant, right?
Hmm.
Like the
Ah,
revenue cannot scale. right? So if I'm replacing a customer with customer, that
Hmm.
meaning that the revenue is always like maybe
Hmm.
around here and there, maybe a constant thing. And also point is that there might be competitors coming into the same space,
Hmm.
and they might also pitch into the same market area,
Hmm.
which also reduce the
Hmm. Hmm.
uh, revenue. Right?
Hmm.
But then if you try to keep the customer over the time, like if you try to retain the customer with other products, right? So I think then it would be a better prospect for the company to grow, right?
How to, at the same time, they should study the problems being faced by, maybe one problem has been solved, or maybe something, uh, it can be enhanced, the texture can be enhanced or something like that, so that
Yep.
you can keep that customer to buy
Right.
your products,
Right.
which can be, I think, a lifetime. It can be a lifetime customer, because that, as far as I can see, the skin treatment is not only for a limited period of time. It will be, it is there when, till the time that customer is live, is
Right.
living. Something or other you will always be needing.
Yeah.
Maybe some basic problem has been solved, but the constant treatment of the skin is always the need of the hour.
Yep. Yep.
Is it? Have I satisfied you?
Yeah.
Huh?
I got the answer.
Okay. Okay. So that is, these are the 10 principles on which material
So
handling is.
we have a team there. It comes under growth.
Hmm.
There's a process called life cycle process at
Hmm.
our org.
Hmm.
I was just I'm just correlating the principles with whatever the subject that I.
I did not get you.
Oh, I'm trying to correlate the principles with whatever the business area that I'm working on. That's all.
So naturally, these things will affect any business. The product and the process might be different, but the principles will be the same, isn't it?
Yeah,
Principles will apply everywhere.
right.
Life cycle principle we have to see. We have to see something in a totality, right from the birth to the death. Life
Right.
cycle. So
Yeah.
the principles, what 10 principles which have we discussed, it will be irrespective whether you're producing something or you're giving services. You have to follow these 10 principles.
Yeah. So I think any business, the life cycle is pretty much a common principle, right?
It is common thing. It is a common thing.
Yeah. Like even for small businesses, right? Like,
Hmm.
the small uh grocery shop or whatever have we
Ah.
have
Hmm.
in our place in our India, right? So
Hmm.
we don't realize that this principle is always there.
Hmm.
But then we just don't know it.
Why, even if you have a grocer, you want to satisfy the customer and you want to retain the customer. As it is said, like we talk about uh, relationship marketing, especially for grocery shop, like you want to retain the customer, because getting a new customer is more expensive.
Yeah.
Retaining a customer is cheaper and a better proposition. That is why we go for what, like these the grocery shops in India, they very much depend on relationship.
Yep.
Maybe they have not studied it,
Yeah.
but
Yeah.
it is, in most of the cases, these things, we many things are on what type of family you come from. So
Yeah.
generally, the people who are involved in businesses, they come from the same community in India, and they know how to handle things. how to keep their cool, how to satisfy their customers. They maybe they have not studied management uh, at some school, but they have been taught all these things in their own family, and they have observed other family members the way they're working, and the face of the customer is familiar to them. They want to know, they know how to retain him.
Right, right. And part of it I was just trying to correlate is my
Hmm.
mom has a small boutique in my hometown,
Hmm.
and and she came to States like few months ago, and then she was there for 8 months,
Hmm.
right? So she had boutique since like last 25 years,
Hmm.
and then she was never out for 8 months at the whole last 25 years.
Hmm.
And the the whole of her business
Hmm.
came down because she wasn't there. Because the shop,
Naturally.
the
Huh.
boutique was running. The boutique
Huh.
was running.
Hmm.
But it's there, like there are people who is taking
Hmm.
care, but the numbers were like so down.
Hmm.
And the reason, and then I realized that, I mean, since you brought up the relationship management, so I was
Hmm.
trying to correlate that. I think my mom's the whole boutique was running on her personal connection, or on her, maybe her, the way that she talks, or the
Hmm.
way that she receives, all it all matters, it seems, right?
It matters a lot. It matters a lot. For
And now
example,
yeah,
in
she came
here, if
back.
a
Oh, go ahead,
suppose
go ahead.
the shop where I go regularly for my grocery and other things, like suppose by chance I don't have money at that time particular, so he'll just say कि अरे क्या है आपसे पैसा कौन मांग रहा है. He also knows that I'll pay, and I know he will not give me without money. But
Mhm.
that thing, when he says that, I become a constant customer of that particular shop. अरे आप ले जाइए, आपसे पैसा कौन मांग रहा है. It is not that he'll give me free. I know that. And he
Yeah,
also knows, not today, tomorrow, day after tomorrow, I'll pay him. He has
right,
that much faith in me. So that
yeah,
is the type of relationship we have built up.
right. It is like local credit system, right?
It's a local credit system.
Yeah, yeah. So these are all there, but like
Yeah.
when it is centralized, like it's
Mhm.
so the credit system, the local credit system only work when you have relationship, right? It doesn't work
Relationship.
have relationship.
Like sometimes in your automation and computerization, some these things are lost.
Yeah,
Like your computer will not understand. If it asks for credit, you immediately have to pay.
right, right,
There are so many. So everything, like every new system, some had advantages and some disadvantages. You don't have any system which is absolutely without disadvantages.
right, right. Yeah.
Like for example, in India, we have servants.
Mhm.
They not only help us, but it is our social network. It also builds our social network. Even in a
Mm.
house, if a lady is a housewife, she can interact with so many people. There are so many people coming to their house to work, so she does not feel isolated. Suppose their husband or children are very busy in their own work, but at least she has someone with whom she can. So it is not only their help, but also their companion. So the society, the way it has been built up in India, is a bit different.
Right.
Okay, so this is all for your, and then we'll move to material handling equipment. So any questions on this? Principles of material handling. These are the 10 principles. Planning principle, standardization, work principle, unit load principle, agronomic principle, space principle, space utilization, system principle, automation principle, environmental principle, and life cycle principle. So these 10 principles, which whatever type of job you are doing, wherever you are doing, these 10 principles have to be followed so that you get the optimum result of whatever operations you are involved in. Is it clear?
Yes, ma'am.
Huh?
Yes, ma'am.
Okay. Okay. Well, this that is quite then the principles. Just one second. Should we do a material handling equipment? Can you see it?
Yes, ma'am.
Huh? Material handling equipment.
Yes, ma'am.
Yanchika, you did it?
Ma'am, it's just principle of material handling.
अच्छा, नहीं, I'm material handling equipment. Okay, I'll share it. Okay.
Okay, ma'am.
Now, can you say it? Material
Yes.
handling equipment.
Yes, ma'am.
The definition, Yanchika?
Yes, ma'am. Material handling equipment MHE is mechanical equipment used for the movement, storage, control, and protection of materials, good and product throughout the process of manufacturing, distribution, consumption, and disposal.
Yeah.
Types. The different types of handling equipment can be classified into the four major categories: transport equipment, positioning equipment, unit load formation equipment, and storage equipment.
So for different type of job, you have different type of equipment. Suppose you want to transport something from one place to another, so you have transport equipment. You have to position something, then you have positioning equipment, unit load formation equipment, and storage equipment.
I learned this in my previous job, ma'am, MHGs and all.
The transport
Basically,
equipment.
the material handling works on 5 Ks, ma'am, right? Transport equipment. Transport equipment is used to move materials from one location to another. Example, between workplace, between a loading dock and a storage area, etc. While positioning equipment is used to manipulate material at a single location. The major subcategories of transport equipment are conveyors, trains, and industrial trucks. Material can also be transported manually using no equipment.
Like you can carry one thing from manually from one place to other.
Another. Transport equipment are of the following types: conveyor, electric trucks, cranes, industrial truck, manual handling equipment. Conveyors. A conveyor system is a common piece of mechanical handling equipment that moves material from one location to another. Conveyors are especially useful in application involving the transportation of heavy or bulky material. Conveyor system allow quick and efficient transportation for a wide variety of material, which make them very popular in the material handling and packaging industry. They also have popular consumer application as they are often found in supermarkets and airports, constituting the final legs of item bags delivery to the customer. Many kind of conveying systems are available and are used according to the various need of different industry. They are chain conveyor, floor, and overhead as well. Chain conveyor consists of enclosed tracks, I-beam, tow line, power and tree and hand pushed trolleys. Example, an overhead chain convey cars and Mercedes in Germany is shown in the next slide.
See, overhead conveyor they have.
Okay. Electric tugs. An electric tugs is a battery powered and pedestrian operated machine used to move heavy loads on wheels.
Like you have electric truck like this.
This one.
And see, the wheels are, it is being moved from one place to another. Then you have cranes.
Cranes. Cranes is a type of machine generally equipped with the hose, rope, wire rope, or chain and shape that can be used both to lift and lower materials and to move from them horizontally. It is mainly used for lifting heavy things and transporting them to other places.
Hmm.
The devices use one or more simple machines to create mechanical advantage and thus move load beyond the normal capability of human. Cranes
Hmm.
are commonly employed in the transport industry for the loading and unloading of freights in the construction industry for the movement of material and in the manufacturing industry for the assembling of heavy equipment used to transport loads over variable horizontal and vertical path within a restricted area. And when there is insufficient or intimate flow volumes such that they use for conveyor cannot be justified.
Hmm. So conveyor, so it cannot be justified. So cranes are used.
Yes, ma'am.
Then you have industrial trucks.
Industrial truck. Industrial trucks are trucks that are not licensed to travel on public road. Commercial trucks are licensed to travel on public roads. Industrial trucks are used to move material over variable paths and when there is insufficient or intimate flow volume
Hmm.
flow volume such that the use of a conveyor
Hmm.
cannot be justified. They provide more flexibility in movement than conveyors and cranes because there are no restriction on the area covered and they provide vertical movement. If the truck has lifted capabilities, different types of industry truck can be characterized by whether or not they have fork for handling pallets, provide powered or required manual lifting and travel capabilities, allow the operators to ride on the truck of required that the operator walk with the truck during travel, provide load stacking capability and whether or not they cannot operate in narrow aisles.
Hmm. Like conveyor can be over, but it is fixed from one place to another. But here trucks are moving; they have more flexibility.
Yes, ma'am.
As it can be used wherever it is required. Like you can use both conveyor belts for some things. For some things, you can use industrial trucks.
Automated guide wheels, industrial truck that cannot transport load without requiring a human operator. Manual handling equipment, commonly used to assist in moving smaller loads where larger equipment would struggle. Manual handling equipment such pallet trucks, trolleys, and sack trucks can be an essential part of any material handling.
So these are the various which we use. So whatever it can be used for wherever according to the need. According to the need, these are the basic things which are being done. Either material is being transported from one place to other, or it is being positioned somewhere, or it can be some unit load formation equipment, can storage equipment can be there, where when the material is not being used, it can be stored properly somewhere. So these are the different four types of operations which are done on the material, and for each you have different type of material handling equipment.
So,
So we have I'll send you the PPT.
PPT.
I think that is all for today. Any questions?
No, ma'am.
Hmm?
No, ma'am.
Okay.
Thank
Okay.
you.
Good night.
Good night, ma'am.
Good night.